Welcome back. Today we examine a critical failure in energy isolation, the dangers of mechanical failure and the vital step of verification.
Hello and welcome. We're HSEEG, the Health and Safety Executives. In this session, we're going to lay the groundwork for one of the most critical safety protocols out there, lockout/tagout. Now, I want you to think of this not as just another procedure you have to follow, but as an absolute, non-negotiable lifeline. Let's get started. We're starting with this number for a very important reason. According to OSHA, proper lockout/tagout procedures prevent, on average, 120 fatalities every single year. You know, these aren't just statistics on a screen, these are our colleagues, our friends, people who get to go home at the end of the day because of the system. And it goes way beyond that. On top of those fatalities, we're talking about 50,000 serious injuries, things like amputations, burns, crushing injuries, all stopped in their tracks every year just by doing this one thing right. The stakes really couldn't be any higher. So this is the whole point. This is why we're here today. We are not talking about some bureaucratic chore or another piece of paperwork to check off. We are talking about a physical, deliberate action that you take, an action that stands between you and a potentially life-ending accident. It's your shield. And today, we're going to understand exactly how it works. All right, let's get right to the core of it. So many incidents happen because of one single incredibly dangerous assumption, the illusion that just because you flipped a switch to off, a machine is safe. We have to shatter that illusion and replace it with the rock-solid principle of a zero-energy state. So what is a zero-energy state? Well, it's the only truly safe condition to work on a piece of equipment. It means the machine is completely and totally cut off from anything that could possibly make it move, cycle, or release energy. And that's not just the main power. It's also any hidden or stored up energy that might be lurking inside its systems. And this right here, this slide shows the critical difference perfectly. Think about it this way. On the left, you've got a control circuit, like a push button. That's like asking the machine to stop. But on the right, you have an energy isolating device, like a breaker or a valve. That doesn't ask, it commands. It physically severs the connection to the power source. There's no room for debate. And look, this isn't just our opinion. This is a direct quote from the OSHA standard itself, the official rulebook. It's completely unambiguous. A push button is for control. It is not for safety. Why? Because control circuits can fail, relays can get stuck, wires can short. For true, dependable safety, you have to physically isolate that energy source. But you know, the best equipment in the world doesn't mean a thing if we don't have the right people doing the right things. So that brings us to the human element, because at its heart, this whole system is really about responsibility and personal control. So there are two key roles you have to know. First, the authorized employee. This is the person who is trained and authorized to actually put the lock on the machine to perform the work. Then you have the affected employee. This might be the machine's operator or just someone who works nearby. They need to know what's happening for sure, but they must never, ever touch or remove that lock. And that leads us to probably the most rigid, most important rule in the entire lockout/tagout system. So let's just pause and think about it for a second. Why is it so absolutely critical that the person who put the lock on is the only person who can take it off? It's because that lock is your personal guarantee of safety. When your lock is on that disconnect, you are the only person on this planet with the key. You have exclusive 100% control. No one else can start that machine up while you are in the line of fire. It is the very foundation of personal accountability. Now, up to this point, we've talked a lot about electrical power, and that makes sense. But it's really only part of the picture. To get to a true zero-energy state, you have to think about all the different ways a machine can store energy and cause harm. Energy, well, it comes in a lot of different flavors. Electrical is the one everyone thinks of, but we also have to deal with mechanical energy from moving parts, hydraulic or pneumatic pressure in lines, and even chemical or thermal energy. And maybe most importantly, we have to control stored energy, the hidden dangers. Think about a heavy part held up by gravity, or a powerful spring that's been compressed. All of these hidden forces have to be isolated or released to be truly safe. Okay, so let's just quickly recap where we are. We've established the why, we know lives are on the line. We've defined our goal, a true zero-energy state. And we've sorted out the critical roles and the hidden hazards we need to look out for. You now have the foundational knowledge. So now you have the core principles that make lockout/tagout actually work. The next big step, of course, is turning that knowledge into action. In part 2 of this HSEEG explainer, we're going to walk through the exact step-by-step procedure to safely achieve that zero energy state every single time. We're moving from the classroom straight out to the field. This is all about execution, the absolute non-negotiable steps every single authorized employee has to follow to guarantee a zero energy state. And let me be clear, there is absolutely no room for error. Okay, let's get right into it. The entire point of lockout/tagout, the whole system, it really hinges on just one thing: flawless execution. A plan, it's worthless if it isn't followed perfectly, every single time. We're not talking about best practices or good ideas here. We are talking about a mandate that guarantees your safety. So, let's be crystal clear. If you're an authorized employee and you're performing service or maintenance, this is for you. We've already covered the what and the why. Now we are diving exclusively into the how. Every detail that follows is absolutely critical. So now we're going to walk through the core procedure. I want you to think of these 7 steps like an unbreakable chain, a chain of survival. Every single link in that chain has to be perfect. Any weakness in any one of them, it compromises the entire system and it puts lives at risk. And here they are. These are the 7 mandatory steps to achieve a true zero energy state. We have preparation, notification, shutdown, isolation, application of your Loto devices, control of stored energy, and the final, most critical step, verification. So let's break down each one. All right, let's start with the first 2. Step 1 is preparation. Before you even think about touching anything, you have to know every single energy source involved. We're talking electrical, hydraulic, pneumatic, even gravity. Once you've got that knowledge, you move on to step 2, notification. You must personally inform every affected employee that the equipment is about to be shut down and locked out. No surprises. Now, here's where things can go wrong. A lot of people confuse shutdown with isolation. They are not the same thing. Shutting down is just using the stop button. It's an orderly stop. But isolation is physically going to the energy isolating device, the breaker, the valve, and operating it. You are creating a physical break between the energy and the machine. Remember this, a stop button is not an isolating device. This next step gets right to the heart of personal control. When you're working on equipment, you affix your lock and your tag, period. And if it's a team job, you use a hasp and every single person on that team applies their own lock. This isn't just a good idea. It's a direct requirement under OSHA's group lockout standard. And the reason is simple. You are the only person in control of your safety. You're the only one authorized to remove your lock. So you flip the breaker. That doesn't mean the machine is safe yet. We have to account for stored energy. This stuff is the hidden hazard. It's the pressure still in a hydraulic line, a compressed spring, or even just a heavy part held up by gravity. This energy has to be controlled. You have to bleed the pressure, block the part, discharge the capacitor. Isolation is not complete until stored energy is at 0. So you've done the first 6 steps. Your lock is on, the breaker is off, all that stored energy has been bled out. The question is it really safe to begin work? Don't just assume, prove it. And that proof comes from the single most important part of this entire procedure. Step 7, verification. We call it the dead test or the tryout for a reason. This is the moment of truth. This is where you actively prove the machine has zero energy. So let's walk through exactly how you do this. First, you clear all personnel from the danger zone, make sure it's empty. Second, you deliberately try to start the machine using its normal controls. You literally push the start button to prove it won't start. Third, for any electrical hazards, you use a properly rated test meter to confirm there is 0 voltage. And finally, and this is so critical, you return all controls back to the off position. Only then have you truly verified a zero energy state. And listen, this isn't just HSEEG's advice. This is a direct quote from the law. OSHA Standard 1910.147 Section D6 mandates that the authorized employee shall verify isolation. It's not optional. It is the final confirmation that separates a safe job from a potential tragedy. So, the machine is verified safe and the work is finally done. But we're not finished yet. Returning that equipment to service requires the exact same discipline and methodical approach as taking it offline. Rushing this step can be just as dangerous. The process is really a mirror image of the shutdown. First, you inspect the whole work area, get all your tools out, any non-essential items. Second, you get all personnel cleared to a safe location. Third, and only then, each authorized employee removes their own lock. Once all the locks are off, the very last step is to notify the affected employees that the equipment is coming back online. But what happens if a lock gets left on a machine and the employee who put it there isn't available? This situation requires a strict, high-risk protocol. Let me be very clear. This is an emergency procedure. It is not a convenience, and it's definitely not a shortcut. This protocol, which is outlined by OSHA, must be followed to the absolute letter. First, a manager has to verify the employee is not at the facility. Second, you have to make every reasonable effort to contact that employee. Third, only after those steps are taken, the lock can be removed under supervision with full documentation. And finally, you have to make sure that employee is made aware of the removal before they even think about starting their next shift. This isn't a shortcut. It's a formal, documented process that guarantees accountability at every single step. We've covered the procedure in some serious detail. But, it all comes down to one simple, powerful concept: personal ownership. Your lock is a symbol of your control over your own safety. And this really brings us to our core commitment here at HSEEG, and it's the single most important thing I want you to take away from all this. The lock you place is the only thing standing between you and a fatal accident. Never, ever trust anyone else's lock. Never assume it's safe. Isolate it yourself, verify it yourself, every single time.
That's all for today. Till the next video, please stay safe.